All right. Welcome back, everybody. So today I've decided, as of after struggling with yesterday's physics-based controller, I think just this is gonna be a lot easier if we just use the normal character controller component to control our character. But I do this time want to use a state machine that a state machine pattern that I worked up a little while ago. So we're going to implement that. Things should be a little bit closer to the script that I had before. Actually, speaking of which, let's Notepad++. Grab this. We don't need that. After I ended the recording yesterday, I added this game loader, which is this fun little thing that allows us to control startup order for our games, and just making sure that things that are singletons are managed by this, and ensures that these any singleton that you might have in the services, that start function, or in this case we'll call it initialize because it's going to be different from the system start function. It ensures that that will be called first before any of the other stuff that's in the scene. So that will be fun. So that's already implemented. I haven't used any start function, so I didn't have to convert anything yet, but it's good to kind of have that in from the beginning. So I'm actually going to quickly just go ahead and grab the state machine from another project that I have it stored in. I'm sure I have it stored in like my resources folder, but actually I'm gonna check there first, just make sure it is there. Scripts should be C# state machine. Yes, I do have it. What do you know? State machine. So basically the idea here is it's all templated. Basically we've got this AI namespace. I'm actually going to put it in the DevTools namespace. And basically you're going to create an interface that's going to inherit from this interface here, which is going to include an enter, update, and exit, and this is the actual state. So update is going to be called on update. Enter is going to be called whenever you go into the state. So whenever you enter the state, so say you have a walking and a running, or an idle and a running state. When you transition from idle to running, enter will be called on running, and then subsequently update will be called on running. And then exit is the same thing, it's just it gets called on the exit of. So say you're going again from idle to running, it'll call exit on idle, and then enter on running, and then update on running, for example. And then we have the actual state machine class itself, which is just gonna manage which state is currently active. And again, agent type, this is just what we're calling our templated thing, because an agent is something that gets controlled by something in AI. So this just has to be a class, that's all this is saying. And we're just basically, the state machine is going to have a reference to the agent, or in this case, let's say it's like the player. It's going to have a reference to the player. It's going to have a list of states, or it's going to have what is the current state, actually, sorry. And then there's the list of states right there. Just making sure that the agent is created. When you create the state machine, you have to provide the agent type. And then there's, what is this? Public void. We're adding a state, so we'll add each of these. And then we'll have an update which calls the current state's update, along with the delta time and change state. You'll also notice that this doesn't rely on anything from Unity. It's all just basic C#. So we'll have to make sure that we're passing, or we don't technically have to pass in delta time. We could still call it, but from time.delta time, but it just makes it a little bit easier if it's just decoupled. So we'll just do that. So I'm just going to go ahead to grab that, copy it, and I am going to save. I'm going to save that, and then let's go to our scripts here. So I'm going to go to external because it is kind of external. have a XephTools folder. And then we're going to create a new script. Where is script? C# script. We're going to call it state machine. Enter that. Since this is not going to be mono behavior, we can get rid of everything and paste in the stuff we just looked at in Notepad. Save that out. So this is no longer going to be a component that we're going to be able to add to the player. This is just going to be something that we're going to create within a component. So yeah, let's go back into Unity here. Oh, I need to grab my debug tools and place those in. I'm gonna put the VR debug here. Is that an external? Yeah, it is. We're gonna move that to XephTools because it's technically in XephTools. It's in the XephTools namespace. I believe it should be. Pretty sure I changed the, yeah, it is, okay. Cool. All right. Now let's go ahead and restart with these. So I'm gonna delete XR character controller. And then player movement, we're just going to do this over again. So we're gonna be using Unity Engine. We're going to create a new public class player movement. That's going to inherit from mono behavior. So there is our basic class structure. And then we're just going to go, there's going to be a problem here. So we're just going to go back to our player and we're going to get rid of this script because it no longer exists. That's fine. We're going to get rid of the capsule collider because the character controller has a capsule collider built into it. We don't need the rigid body anymore. Just gonna remove component there. XR origin stays the same. We can get rid of our ground check. We can get rid of the ground check script because the character controller has a ground check in it already. Camera offset, everything should be good here. Yeah. All right. Pull up my stream health here just so that I can see. Cool. Great. Cool. Player movement. So we're gonna get the character controller here. What kind of stuff do we have here? We're gonna have to adjust that player height again based on what we had last time. Can I move this up, please? Thank you. Slope limit 45, step offset 0.3, skin width, sure. I don't need to really worry about. So we're gonna need to adjust the height again. Layer overrides. No. Okay, so player movement. Going to add a component. So we're going to require component type of character controller. And then we are going to have that private character controller, controller, and void awake. We are going to go get that. Cool, good start. Let's go get our movements here. So this is going to be the inspector stuff. So we're going to do a header. Always important to keep your inspectors organized, especially at the beginning, because then stuff just gets bigger and bigger and bigger and bigger, and then you don't know where you are. So this is going to be inputs. Then we're going to serialize field, put action reference. This is going to be move input. Sorry, does not go like that. Duplicate this 2 more times. We'll have the jump input, and then there was one more input that I had here. Wasn't there? Let's go look at our inputs here. Engine controls, main input. Nope, just the 2. Alrighty. Yoink. We did have an on jump function. So let's, we're gonna need a void. Let's do check move. Make that explicit, check move, then we'll have a do jump. Sorry, pardon my C++-ness. I'm used to making header files in C++. Let's have input events. I'm gonna check my Notepad++ for how I was calling move before. Was I calling it on update or fixed update? I was, okay, climb. Move was in the XR character controller, which is really dumb. It's just in update, okay. Do I want to call it check move? No, I'll call it move. We'll check the move in the update. Do jump, and then we'll have a void on jump input. It's going to be private. And this is going to take an input action.callback context. And we're going to grab, so on awake, we're going to call jump input dot action dot performed plus equals on jump input. Copy that line. Go create a on destroy. On destroy, paste that and unsubscribe. We're going to grab I actually want to see what do they say anything about if it should be called an update or fixed update? Update move causes, what do they call it here? They just call it, yeah, so they call it an update. This just saying C#. Okay, cool. So we'll call it an update. So so yeah, I'm just gonna make it very precise movement to start off with here. So so we should have a move input. So if, let's throw an error up here. I'll do that later. So we're gonna say if move input dot action dot read value vector 2 dot square magnitude is greater than 0. So basically what this is, if you don't know, square magnitude is a lot cheaper on the CPU performance because it doesn't require a square root. Square root can be very expensive. So, and we don't need the actual magnitude for this. We just need to check if it's greater than 0, and 0 squared is 0. So we're just checking to make sure that we're actually moving. If the magnitude is 0, so that could be in any direction. If the magnitude is 0, then we're not moving. So, so if that's the case, we'll move. Let's actually grab that and pass it in vector2 axis. So we'll grab that. So vector2 move axis is equal to that, and then we will check if move axis dot square magnitude is greater than 0, and then we'll pass in move axis. So we'll check. Really? Actually, this should be in the state machine. What am I doing? Okay. Cool. So we're gonna get rid of that. We're gonna do the state machine now. So the state machine, we have the player script. I'm gonna create a new folder called player states. And then within that, we're gonna add new item class, and this is going to be called states. We're gonna be using XephTools. So we're gonna have public class player idle, or player grounded, sorry. There's going to be I state of type player movement. We're gonna have one called player airborne. And then, let's see, so we got grounded, airborne, and there'll be more as we go along here. So we'll create the public void update float delta time. Are you supposed to specify override? Pretty sure you're supposed to specify override in C#. What's that? No suitable method or function override. Let's go double check what we had here. Public void. Oh, we need to pass in the agent. That's it. The states. Agent type is player movement. No suitable method. Public void update interface where agent type is class. Hot reload? Yeah, no, I haven't. I need to look into that a little bit more. Thanks for the recommendation though. Because every time I thought I just did it by default, but then you get like the mono behavior missing something or other when you hot load it. But yeah, no, I didn't see any messages last time, so thanks, man. All right, why am I feel like, why am I so dumb here? So do I just like show potential fixes, extract base class? Nope. What did I do last time? I'm gonna check. Because I've used this in another project, so I'll just go double check on how that was overrided there. It was 2D. Assets, scripts, player, states, player airborne. Oh, that's the meta, sorry. We went with C# script. What did I do here? Player movement, else if, so I didn't override it. There's no override keyword. Including was for that? The other recommendation: avoid jumping into the headset until absolutely necessary, including for that ground check logic. Was the solution? Sorry, I'm not quite understanding. You can expand on that. What was the solution? Was the solution to go over to the character controller, or? Because yeah, that's the thing about VR game development. If about like not having to jump back and forth into the headset is like, it's amazing if you can figure out how to do that. Yeah, so no override. But yeah, I get confused between, I write a lot of C++, so that's why I'm like, do I include override or not? I don't know. But yeah, so we've got update. I'm gonna grab update in here as, oops, we're not cutting, we're copying. Thank you very much. Oh yeah, no, we're just, I'm going back to using the character controller, like the built-in Unity character controller, just because it's like, that's what I used last time. I would definitely, like, for a 2D game, because I used a rigid body in the last 2D game I made, and it worked really well. But I don't know, I feel like for 3D it's just good to have the built-in character controller, because it has like the steps and the stuff. You don't have to do that yourself. I also had this working in a like, I have a demo of it in a previous version of Unity. I just want to remake it and kind of abstract it a little more, like I'm doing this state machine thing to try and make it a little bit more abstracted, because before it was super, like, a lot of dependency injection between a lot of different things. So we're trying to decouple it a little bit here. But yeah, we're just we switched over to the character controller. Yeah, okay, cool. So update is, so we're gonna do the, so we're gonna get the input from the player movement. So player movement, we're gonna have a, well, we're gonna have a private first. Move. We have move inputs, move axis. This is gonna be a float. No, it's gonna be a vector 2. Move axis is going to be equal to 2.0. Then in update, we're gonna update that with the move input dot action dot read value vector 2. And that's going to be called, oops, that goes out there. And that's going to be called before we call our update on our state machine. And we need, speaking of the state machine, we need our private state. Oh yeah, we're using Zeph tools. State machine of type player movement. And that's going to be a new state machine, player movement. Good. Oh, and then we need to provide this. So we need to call this an awake, this part. So awake, I'm gonna grab that. All right, so we're passing in this, then we're gonna need to add our states, but we'll do that in a second. So we're gonna have that, and we're gonna have the public move axis. Vector 2 move axis. Just gonna double check here. Okay, cool. Is going to be get return move axis, and we're not going to set it. Just need to read it. Let's make this internal, actually. State machine. You can get rid of that. Player movement, states. It's called states. Oh yeah. I'm gonna call it player states.cs. Cool. So here we will be able to then get agent dot move axis, which is good. So let's pass in move speed as well. So this will be serialized. What am I going to call these? These are, what's the technical term for these? My C# brain. Because we don't have these like special get set things in. Is it no, not parameters. Not properties? No, these are properties. It's not interface. This is an interface. Jeez, I'll rename it later. So we're gonna need we do need some header parameters. We'll serialize field, float, move, speed, and ground, and air. We'll private. This is under here. So internal float, move, speed, ground. Get move, speed, ground, and then we'll do the same thing for air. Cool. So we have those. So then we'll say if agent dot move speed, no, move axis dot square magnitude is greater than 0. Then we'll do our move stuff. Move, am I passing in? Because we have this, I'm just gonna have a move. I'm just gonna use this, but this is now going to specify this is gonna specify which speed we're using. It's gonna be internal. So we'll call agent dot move with the agent dot move speed ground. We can grab this guy. This will be move speed air. So that should be good, so that we actually don't need these for now. I'll delete them later, just in case I do need them. Oh no, sorry, I need these. Yes, I need these. What did I not need? Is there something I didn't need? No, I need move axis and I need both of these. Okay, cool. Great. So yeah, move is then just going to be controller.move. And that's going to be, so we need the vector 3. Velocity is going to equal vector 3 dot. All right, let's just do it this way. New vector 3. And I'm gonna call, so it's gonna be X and Z. So no, I don't want that. I want the move axis dot X. guess we can multiply it by this speed now. 0. And move axis dot y. Great. We'll move by velocity. Sorry, this needs to be multiplied by the speed as well. And then I believe this is called an update. We need to, yes, because we're moving a certain amount. So should need that. Because this is going to be called from state machine dot update with dot delta time. And this, no, that's the this is called from the state machine itself. Okay, cool. Airborne, the one thing that airborne is going to do is it's going to check ground. So let's get player movement, internal bool check ground. Well, let's do this as one of these things. So we're going to return the character controller dot is grounded. Good. So we're going to say if is, sorry, agent is grounded. Then we're going to call a land function. This will be of the agent. And we're gonna need access to the state machine. And we're gonna call change state to, we're going to create a public enum, player states, which is going to be grounded and airborne. And then we're going to pass in the int, because this was made generically, of player state dot airborne. While we're here, we're going to, I'll move this up a little bit, and then we'll add the state machine dot add state of type player grounded was the first one. I have to make sure it's in the same order here. Yeah, so grounded, then airborne. Player airborne. Cool. And then it should default. The other thing we need to check. This should be on exit. Let's do that. Oh no, never mind. We don't want that because we might be exiting to a different state. Just create this on land. On land. There we go. That's being called. And so we need to do something similar here. If we fall off a ledge, we need to transition to airborne. Just going to check if it's not grounded. Don't need to call that. Oh, sorry, this needs to change state to import, and this needs to change state to grounded. Correct. The other thing that we need to do here is we need to call gravity. How do I want to set up gravity? Let's do apply gravity. So that'll just be called here. This is from the agent. Apply gravity. Cool beans. Apply gravity is then we're gonna need our gravity. And then we'll just apply that. How did I do this before? I just call move. How did I do this? Controller update. What does controller update? Oh, controller changes the position of the, we'll need to do that eventually. Set gravity enabled, gravity toggle gravity set to. Is gravity its own? Is gravity its own component or something? Oh, it was. Oh, you know what? I think I used a gravity from like an asset pack or something, because I couldn't figure out an issue. I might just yoink that. VR, old, assets, okay. Did I store it in scripts? Player, hand, player. No, it's gonna be in a, we'll be in, oh, hexabody. Hexabody? Let me look here. Windows search sucks. Grab everything. It's in assets libraries. So this was the script that I used before. I think I might just, yeah, because I added this function, set movement Y, multiply movement Y, get movement Y. I'm just gonna grab this, honestly. Let's go back here. I'm gonna put this in external. BNG, I believe, is the namespace. Player controller type, rigid body. There's obviously something missing here. Yeah, okay. Maybe not. Maybe we won't do that. So we'll just apply gravity. So that's gonna be, because that was one thing that was really annoying me in the previous version of this character controller, was that I had like gravity was being turned on and off for different abilities and stuff like that. And whereas now with this state machine, only the states that were currently in their update will call that gravity, which will make it so much easier for me, I think, in the long run. So apply gravity is then going to take the character controller dot move its acceleration. So we're gonna take, so we need to grab that velocity. Character controller dot, is there velocity dot y? Cool. We'll store that as a float. Y velocity. The velocity dot y. Cool. And then we're gonna say the velocity is going to equals gravity controller dot move is going to be vector 3 dot, it's going to be dot up because the gravity is negative. It's going to be multiplied by y velocity. Okay. Cool. I'm not going to worry about jump just yet. Let's have an internal, just because I see myself using this later, reset. Reset y velocity. And that's not gonna do gravity, but it's gonna say character controller dot velocity. Is it gonna allow me to do that? No. Cannot modify it. So we're gonna say that it is a new vector 3 Oh, you can't even update it at all. Ah, I see. It is read-only. Great, what did I just do? I think we might need an internal velocity. Did I have a velocity in this move vector? Climb move, grapple move, fall dampers, move input, move vector. I read this twice, that's gross. Hate that. Turn input, jump input, controller update. VR controller set gravity enabled. Right. No, we just moved by an amount. We didn't move. Where's character controller.move? It's in. Jeez. Climb, move, grapple, move, move, move. Here we go. Get us climbing. See, this is the kind of stuff that our state machine will fix, is doing all these if statements. Forward, yeah, that's standard forward stuff, right? Oh, right, because we're gonna need to do this crap too. I just want to get it working first though. Yeah, we're just calling it here. We don't have a velocity. Gravity, I think, compounds though. Okay. So that's gravity amount. All right, let's rename this property properly. So gravity amount, and then we're gonna have a internal and then that is going to be reset on land. Apply gravity is then going to, we don't need this. This is going to be gravity. There we go. Reset y velocity is going to be gravity equals 0 as well, which then, and on that case, we can call reset y velocity here. Perfect. Okay. Do jump, I think, is the last thing that we're going to do. So if we are grounded, we're gonna get rid of, how am I gonna do, how do I want to do the jump input? Jump can be, because ultimately I would like to check it in here. There, I would like to have a Boolean that checks it here, but the execution order may make that difficult. Though I guess, I'm pretty sure input is called before like the input polling is done before update. So we should be good. It's a matter of canceling. But I guess I can cancel it in here. So let's do that. So we'll have a bool jump this frame. And then we'll have an internal bool jump this frame. It's gonna get, and then we're also going to set jump this frame equals value. So if is grounded. Cool. Checking that. Snot is grounded. Changing states here. So I want that to be the last thing that I do. So if agent dot jump this frame, agent jump this frame is false. And then we should always be able to jump if we're grounded. There's no need to check. We'll need to do a check in airborne once we get the double jump, but so jump this frame, false, and then we're gonna do our jump. So jump, jump. What was the function? Player movement. Did I create one? Pretty sure I created one. Do jump. That's it. or I made that private. Internal. There's the solution. Do jump. Perfect. And do jump. This actually, I don't want to call it gravity. I want to call it just Y velocity. Yeah. Y, so Y velocity is going to be, we need another serialized field here. Jump velocity, I think 5 was a good number to start off with yesterday when we were doing this. Y velocity equals jump velocity. This needs to be multiplied. Oh no, sorry, this was, yes, but this also needs to be time by that delta time as well. And then on jump input, jump this frame equals true. Hopefully this will all work. That's the thing with programming a lot and not testing it, is that now we have, what is this, shader keyword filter? Get rid of you. So this should be pretty much everything. I'm gonna put this on a new line so that we have it. I wonder if I should break these up into different files. Maybe not. All right, so I'm gonna go ahead and give this a shot and see what we got. Let's jump over into the editor here. We'll grab our player. We need our inputs here. Controls jump and move. Move, speed, air. I didn't set defaults for those. Let's set some input defaults just in case. 3 and 2. All right, let's give this a try. We've got box colliders. Let me just double check. So we're gonna need to set these again because they were already serialized. Jump velocity 5. We've got a gravity amount. Great. Cool. Hang on, actually, let's, the center should be above. Let me just grab what I had in here. Controller update. This is the height. What's setting the height here? Grab that. This is going to be private. We spell it correctly. And we're going to need the camera transform. I'm just going to serialize that. Let's create header reference. Serialized field transform. Nope. Get rid of those. That's going to be camera. Camera, vector 3, position, camera, local position. The height is equal to the position, the Y position, that's correct. New center is going to be the position.x and position.z, with the Y being half the height. Hopefully. We'll see. I might have to add the radius again, like last time. This should work for now, though. So that positioning there shouldn't matter because it will get updated later. All right, let's give it a try. What the heck happened there? We forgot something. Oh, I need to get rid of this logging stuff again. I hate the logging stuff. Zestful state machine. No instance. Agent is agent. Delta time, current state. Does current state, I guess current state doesn't get set. So we got to set the current state in the awake function here. So add, so state machine dot current state. Let's say, or no, we want set. Change state, that's the one. Let's put 0. Or no, we'll do it this way. Clear state grounded. Also, I don't believe I dragged the camera component in, so we got to do that. Great, that should be it. All right, so we got a few weird behaviors. A is I'm way too tall, so that that setup there, I think because I zeroed out this camera offset, that is just, I don't know what's going on there with that height. The other thing is the jump is like really weird. It doesn't respond. So we may just call a jump function in here. And then I'm going to sort out the character controller height first, though, I think. Oh, we're not calling this. That's why. I'm so dumb. So on update, let's get that input. Let's do controller update. I'm gonna call this, for the controller update, I'm gonna call it Collider, because that's a little bit more descriptive. So I'm gonna try that again. Oh yeah, that's way better. Oh, jump actually is working better too. Cool. Nice. I'm gonna create a little jungle gym here, similar to what I used to have. Environment. Let's add a cube. Good old cube. Let's make it nice and big. And we're going to move it up. Let's duplicate it, make it skinny and long, and then rotate it. There. Come on, move. That should be good enough, right? Yeah, that's fine. And then we're gonna duplicate that, move it up here, duplicate that, move it over here, make it taller, and even taller. And then let's make another one here. Duplicate it, make it skinny, and oops, I lost it. Be this, no, it'll be 5. There we go. Cool. Let's grab some materials, some colors to make our life a lot nicer. Some nice blue. And then, oops. Then we'll make these stairs, or the ramps themselves. Let's make them white. Maybe light gray. Light gray is good. Cool. We'll give it a try. See everything from up here. Interesting artifact there. I need to change my shader for this thing. Yeah, anyways, the thing that's bugging me is it's all in world space. I can't like look somewhere else. So let's fix that. Actually, I don't know if you can hear me because I was talking over there. So everything's working great here. We just need to make sure that we're either doing head or hand-based locomotion. So let's do that. Just gonna get our player. Oh yeah, we're gonna need to edit. Let's just go over here. So parameters, that's fine. References, we got the camera. The camera will be what we'll use to get the forward. I'm gonna call this settings. I'm gonna get us header settings. Oops. Header settings. Serialized field. We'll use HMD locomotion. I'm gonna set it to true because I like HMD locomotion. Use HMD relative. It's called display. Just for the naming in the inspector. Okay. So that's going to be in move. Move. So yeah, we've got our velocity, which we're going to use to move. But we're not actually going to use this yet. So we'll have if use display relative, else left controller relative, just so that we have, so adjust for spacing. Or actually, I'm gonna set this different. I'm gonna say we're gonna have a vector 3 forward, which we're gonna set based on the use display relative. So if it is used, then we're gonna use camera. Dot forward. Under references, we're gonna need left controller. So then we're gonna do left controller dot forward. Cool. Then what we're gonna do is we're gonna get rid of the Y. Because we don't really care about up or down. And then we're gonna normalize it. And then, how did I do this over here? Camera, right. I need right as well. Sure, okay. Right is basically the same. It's the same formula. great. And then we're gonna apply that, which was so that should work. Put some comments in there just to make sure. Okay. Cool, perfect. It's working great. I'm just gonna change the shader real quick. This is like basically unrelated, but is this surface type transparent opaque? Save asset, just because it's kind of been bugging me. Hello? Oh, it's kind of dumb. Do I have it? Oh, color. There we go. That should work. Now it's gonna actually obstruct this instead of making some weird visual artifacts. That will be good. Cool. All right. What's next? I could get rid of these logs, but I think I'll just do that off camera. We could start with some other, we could do some other movement things. Or I can make this velocity based, is what I can do. Yeah, because I could have a total velocity that gets applied. We might do that instead, actually. So instead of calling move here, we can just call the actual character controller move in update after all these things happen. And then we can use this to update a velocity thing. So let's do that. I'm gonna change this to velocity. And it's going to be a vector 3. It's going to be a vector 3, 0. Then we're gonna get some errors. Y, gravity amount. We're not gonna do that. Great. And then here, we're going to say it's going to equal great. Then after this is done here, we're gonna say character controller dot move the velocity times time dot delta time. So I have a move, and then we'll have a decelerate. So we can have move speed air, move speed ground. We can have a serialized field float. Friction ground equals 0.9 and friction air is 0.2. Friction how do we do this? Decelerate. We don't need if. We need basically I don't even know if that's gonna work. So we've got a fraction like 0.9, and we gotta. No, we're gonna do that. Okay, yeah, because gravity is taken care of in its own function, so we don't need to worry about it. Now I have to worry about like overshooting. So let's create. The thing is that I don't really want to be subtracting a specific amount. I guess it is velocity. Let's just give this a try. We'll just give it a try. These need to be greater than. Oh, I really don't like this actually. This is gross. I'm just gonna lerp. Yeah, we're just gonna use So we're gonna get because we only want to do, yeah, so let's just do vector 2 here. Vector 2. Each velocity is going to be new vector 2. No, it's going to be velocity.x and velocity.z. Then 2h. No, I'm just going to say h. Velocity equals vector 2 dot lerp. That's going to be h velocity we want more friction. More friction is going to go towards the 0, which is good. Okay, cool. And then we're gonna say velocity is going to equal to a new vector 3 is going to be h vel dot x velocity dot y and h vel dot z. There's no z, it's y. Okay, cool. That should work. If, and we'll say if vel dot square magnitude is less than very small amount, or let's just call float dot epsilon, then we can set it to 0. And let's just make sure we're not having to do this if we don't need to. Square dot magnitude. Yeah, I guess this doesn't really, we can just do that. All right, I like that a little bit better. Should we make these, we're gonna make these range 0, 1. Apply these. So else agent dot decelerate agent dot friction ground and the same thing in airborne friction air, and then we need to make those things. that should make our movement a little more smooth. It should also allow us to perhaps do some calculations for the climbing and make it so that you can throw yourself up. Because that I would like. That would be good. Because that would be an improvement I'd like to make over the last one. All right, let's try that. So we kind of got the opposite thing going on. So I actually don't want to add, this was a dumb idea, over here in my move. I don't actually want to add that. I want to set it. And then deceleration is happening really quickly. So let me just tweak that. See if in fact it is just this slider. Let's make it really slow. No, it's not working at all. Also, my ground plane is my shader. I messed it up too much. Let's look back at this. That's the problem. Don't need delta time. We also don't need this now, because I can just do that. Great. And we'll try that. So we're not applying gravity while we're moving, which kind of sucks. Oh, because we've got that thing. This. Yeah, so we do need that. And then There we go. That'll work for that. The reason we're not seeing the deceleration is because the axis is not a button input for the move axis, it's the stick. So yeah, I will probably just leave it, and it'll still, this decelerate should still work if we were to like throw ourselves somewhere, like grab onto a ledge and like sort of throw ourselves. That would still work as long as you don't touch the stick. We'll see how it is when we get to it. That's fine. I can take it out later. I can take this out later if I want. Yeah, okay. I'm just gonna test the gravity. I do think we're a little bit chunky though. What's our radius? Radius is half. Let's make it 0.3 after we pause. Yeah, we've got that weird stepping effect on the way down the slope. I'll think about that a little bit more. But yeah, I think that'll be it for today for the stream. We successfully got our basic movement controls working for our player. And yeah, hopefully I'll see you guys in the next stream. Shout out to Beard or Die for making some comments. If you see this later, happen to watch it later, thank you very much. But yeah, see you guys in the next stream.